It's got to be clear. It's like, man, this is sustainable energy cars. It can be the fastest cars, can be the safest cars, can be the most kick-ass cars in every way.
For years, the electric vehicle industry has been locked in the same race: bigger batteries, longer range, and faster charging. But what if the next major breakthrough isn't a better battery at all? Recently, reports connected to Elon Musk and Tesla have sparked serious discussion about a new energy system that could completely change how EVs work. Some experts believe it could reshape the industry, while others aren't quite sure what to make of it yet. So what exactly is going on, and why is everyone suddenly paying attention? How the EV revolution really started. When people think about electric vehicles, Tesla is usually the first name that comes to mind. But the truth is, the EV story started long before Elon Musk became the face of electric transportation. Back in 1996, General Motors introduced the EV1, one of the first modern electric vehicles available to the public. Technically, customers couldn't buy it outright. Instead, GM leased the cars to selected drivers in California. Surprisingly, many of those drivers loved the experience. The vehicles were quiet, efficient, and unlike anything else on the road at the time. Then, something strange happened. General Motors eventually recalled every EV1 and removed them from service. Most of the vehicles were destroyed, creating one of the most controversial chapters in automotive history. To this day, many EV enthusiasts still point to the EV1 story as one of the biggest what-if moments in the industry. The real foundation of today's EV market started taking shape during the early 2000s. Advances in lithium-ion battery technology began changing what was possible. These batteries were already being used in consumer electronics, but engineers realized they could also power vehicles. Compared to older battery designs, lithium-ion batteries were lighter, more efficient, and capable of storing much more energy. Suddenly, electric cars looked far more practical than before. As battery technology improved, automakers started investing heavily in the same basic formula: build larger battery packs, improve energy management software, increase driving range, reduce charging times, repeat the process. Tesla accelerated this trend dramatically. When the Tesla Roadster arrived in 2008, it shattered the stereotype that electric cars had to be slow and boring. Then, in 2012, the Model S proved that EVs could offer impressive range while still delivering luxury and performance. Those successes forced the entire automotive industry to pay attention. But despite all the competition, most companies were actually following the same roadmap. They focused on larger battery packs, faster charging systems, improved cooling technologies, and lower production costs. Everyone was essentially trying to improve the same underlying technology rather than replace it. For years, that strategy worked. Battery range improved, charging speeds increased, costs slowly came down. Consumers gained more confidence in electric vehicles. However, every technology eventually reaches a point where progress becomes harder. And that's exactly what started happening with lithium-ion batteries. One of the biggest challenges is energy density, or how much energy a battery can store relative to its weight. During the 2010s, improvements came fairly quickly. But as engineers pushed closer to the limits of lithium-ion chemistry, progress started slowing down. Charging presents another challenge. Fast charging improves convenience, but the extra heat can gradually affect long-term battery performance. Then there's the supply chain problem. Modern batteries require enormous amounts of lithium, cobalt, nickel, manganese, and other critical materials. Many of these resources come from specific regions around the world, creating potential vulnerabilities in global supply chains. Ironically, while electric vehicles were designed to reduce dependence on oil, the industry ended up creating a different kind of dependence on battery materials. As the EV market continued growing, these challenges became increasingly difficult to ignore. And that's where the story takes an unexpected turn. Because while most companies were focused on improving batteries, Tesla and SpaceX engineers may have been exploring a completely different approach behind the scenes. The Tesla-SpaceX connection that has people talking. In 2024, reports began circulating within engineering communities about an unusual project connected to both Tesla and SpaceX. At first, most people assumed it involved another battery upgrade. After all, Tesla constantly works on improving battery chemistry, manufacturing efficiency, and vehicle performance. Those kinds of developments happen all the time. But according to technical discussions emerging from engineering circles, the real story may be something much bigger. Instead of simply improving batteries, the project reportedly focuses on changing how energy moves through an electric vehicle altogether. That distinction is important. Improving batteries means making the current system better. Changing how energy is processed means redesigning the system itself. And that's where SpaceX enters the conversation. The idea reportedly draws inspiration from principles used in SpaceX's Raptor rocket engine program. It's about applying similar engineering philosophies. The Raptor engine became famous because of its incredibly efficient, full-flow staged combustion cycle. For decades, many engineers believed this concept was too difficult to implement successfully. The pressures, temperatures, and precision requirements were extreme. Yet SpaceX eventually made it work. The company spent years testing prototypes, learning from failures, and refining designs until the technology became operational. The key idea is energy recovery and minimizing waste throughout the system. That same philosophy may now be influencing Tesla's work. Traffic conditions, cold weather, steep hills, rapid acceleration, and high-speed driving all affect overall efficiency. To compensate, EVs rely on increasingly complex energy management systems. The proposed architecture reportedly takes a different approach. Instead of processing energy through a single continuous pathway, the system breaks energy conversion into multiple optimized stages. Each stage operates within its own efficiency range. Energy that would normally be lost as heat is captured, redirected, and reused whenever possible. Think of it like recycling energy inside the vehicle before it ever has a chance to go to waste. The concept sounds simple when described this way, but implementing it requires extremely sophisticated engineering. If the reports are accurate, early testing suggests efficiency gains that could significantly outperform current electric motor systems under real-world driving conditions. And that's where the excitement begins. Because if those efficiency gains prove achievable at scale, the implications extend far beyond Tesla. They could affect battery sizes, manufacturing costs, vehicle weight, charging requirements, and even global supply chains. Suddenly, the conversation shifts from how do we build better batteries to do we need as many batteries in the first place? And that question alone is enough to get the entire industry paying attention. Why efficiency could matter more than range. If the reported efficiency improvements are real, then we're not just talking about a faster electric motor or a slightly better battery. We're talking about a change that could affect almost every part of an electric vehicle. And here's where things get really interesting. When people hear that a system could be 30 to 40% more efficient, many immediately assume it means the car will be 30 to 40% faster. But that's not actually how it works. The real advantage is much bigger than speed. Think about it this way. If a vehicle can use energy more efficiently, it doesn't need as much stored energy to travel the same distance. In simple terms, you can achieve the same range with a smaller battery. That single change creates a chain reaction. Smaller batteries mean less weight. Less weight means the vehicle requires less energy to move. Lower energy demand means you can potentially reduce battery size even further. It's a cycle that starts working in your favor instead of against you. And every time the vehicle accelerates, brakes, climbs a hill, or changes direction, the motor has to move all of that mass. This creates what some engineers describe as a weight spiral. Larger batteries increase weight, which can reduce efficiency and create additional energy demands. And the cycle continues. For years, the industry accepted this trade-off because battery technology was improving quickly enough to justify it. But what if there's another way? What if, instead of constantly adding more battery capacity, engineers could make better use of the energy already available? That's why some researchers find this idea so intriguing. A major efficiency improvement doesn't just affect performance. It affects manufacturing, design, costs, materials, and even infrastructure planning. Imagine an EV that achieves the same range using significantly fewer battery cells. Manufacturers would require fewer battery materials overall. Supply chain pressures could ease dramatically. Production costs might decrease. Vehicle weights could drop. Handling and efficiency could improve at the same time. And the benefits wouldn't stop there. Smaller batteries also mean shorter charging times. A breakthrough in efficiency could help solve several long-standing challenges. This is why some engineers believe efficiency may ultimately prove more important than raw battery capacity. For decades, the conversation has focused on storing more energy. Now, some experts are asking a different question. What if the bigger opportunity is using energy more intelligently? Of course, there are still many unanswered questions. Early results are one thing. Mass production is another. Many promising technologies perform well in laboratories, but face unexpected challenges when scaled to millions of vehicles. Reliability, manufacturing complexity, maintenance costs, and long-term durability all matter. That's why engineers remain cautious. But the potential is difficult to ignore. And perhaps the most fascinating part of the story isn't the technology itself. It's how the rest of the industry is responding. Because for something that could potentially reshape electric transportation, the reaction has been surprisingly quiet. Why the auto industry is suddenly so quiet. Normally, when Tesla announces a major breakthrough, the automotive world reacts almost immediately. Experts publish analyses, engineers debate technical details, competitors rush to explain why the technology will or won't work. Social media fills with arguments. News outlets publish endless opinions. That's the usual pattern. But this time, something feels different. The response has been noticeably restrained. Not dismissive, not overly enthusiastic, just quiet. And in the world of engineering, silence can sometimes be more revealing than criticism. When Tesla introduced the 4680 battery cells, industry experts quickly dissected every aspect of the design. When structural battery packs were announced, competitors openly discussed the strengths and weaknesses of the concept. There was no hesitation. People knew what they were looking at. This situation appears different. Several well-known engineers have acknowledged the reported technology without offering strong opinions. Others have simply stated that more research is needed before reaching conclusions. That's an important distinction. In various technical discussions and industry circles, some researchers have reportedly suggested that the theoretical foundations behind the concept make sense. The questions aren't necessarily about whether the science works. The questions are about whether the system can be manufactured efficiently, scaled globally, and remain reliable over many years of real-world use. Those are very different concerns, and they are concerns that often appear when a technology has genuine potential. Even more interesting is the reaction from major automakers, or perhaps the lack of reaction. Many large manufacturers have remained surprisingly quiet. Most major automakers have largely avoided commenting publicly. Of course, there could be several explanations. Maybe companies are still studying the technology. Maybe they don't consider it important enough to discuss publicly. Or maybe they're trying to understand what it means before revealing their opinions. Whatever the reason, the quiet response has attracted attention. Because industries rarely remain silent when they believe nothing important is happening. We're not necessarily at that final stage yet, but some observers believe we're moving in that direction. And if that's true, the biggest story may not be Tesla itself. It may be the industries that could be affected if this technology eventually succeeds. Because whenever a major technological shift occurs, there are always winners and losers. And in this case, the list of industries that could be impacted is surprisingly long. From battery manufacturers and mining companies to charging networks and energy providers, a breakthrough in efficiency could create ripple effects throughout the entire transportation ecosystem. That's why so many people are paying attention. Not because the outcome is guaranteed, but because the possibility alone is difficult to ignore. The industries that have the most to lose. Whenever a major technological breakthrough happens, people usually focus on the companies that stand to benefit. But sometimes the more interesting question is this: who could be affected if the technology actually works? If the efficiency gains being discussed eventually become reality, the impact could stretch far beyond Tesla. In fact, some of the biggest consequences may be felt in industries that most consumers never think about. Let's start with battery production. For years, the EV boom has been driven by one simple assumption: future electric vehicles will require larger and larger amounts of battery materials. That belief fueled massive investments across the globe. Companies poured billions into mining operations, processing facilities, battery factories, and supply chain infrastructure. But what happens if future vehicles need significantly fewer battery cells? Suddenly, those long-term projections start looking very different. Instead of increasing demand, a major efficiency breakthrough could reduce the amount of raw material required for each vehicle. That doesn't mean battery production disappears. Far from it. Electric vehicles will still need batteries, but the pace of growth could change dramatically. And in industries built around long-term forecasts, even small shifts can have massive financial consequences. The lithium industry is a perfect example. Over the last decade, lithium became one of the most valuable resources in the energy transition. Mining companies expanded operations across Australia, South America, North America, and other regions to keep up with expected demand. Now imagine a scenario where every EV requires 30% fewer battery materials than expected. That's not a small adjustment. That's a fundamental change in the equation. And lithium isn't the only material affected. Cobalt could face even greater pressure. For years, battery manufacturers have tried to reduce cobalt usage because of cost concerns, supply limitations, and ethical questions surrounding mining practices. A major reduction in battery requirements would accelerate that trend even further. The same applies to nickel, manganese, and other critical materials. Then there's charging infrastructure. Around the world, governments and private companies have spent enormous sums building charging networks, fast chargers, charging stations, grid upgrades, and supporting infrastructure all rely on assumptions about how EVs will operate in the future. If vehicles become dramatically more efficient, charging habits could change as well. Drivers may need fewer charging stops. Vehicles may travel farther on the same amount of stored energy. Demand patterns could shift. Again, this doesn't mean charging networks become obsolete, but it does mean long-term planning becomes more complicated. Even energy providers are watching these developments closely. Utilities have spent years preparing for increased electricity demand as transportation becomes more electrified. Forecasting future energy needs depends heavily on assumptions about vehicle efficiency. A major shift in efficiency changes those calculations. And while much of the conversation focuses on electric vehicles, traditional energy industries are paying attention too. Oil companies understand that transportation is one of the largest sources of fuel demand worldwide. Every improvement in EV technology has the potential to influence future fuel consumption. That's why energy companies invest heavily in forecasting transportation trends. The reality is that technological breakthroughs rarely affect only one industry. They create ripple effects. And the larger the breakthrough, the larger those ripple effects become. Whether this technology ultimately delivers on its promise remains uncertain, but if it does, the consequences could extend far beyond Tesla's balance sheet. What this could mean for the future of transportation. At this point, it's important to take a step back and look at the bigger picture, because this story isn't really about one company. It's not even about one engine or one technology. It's about how innovation happens. For years, the EV industry has been moving in a very specific direction. Manufacturers focused on larger batteries, faster charging systems, and expanded infrastructure. Modern electric vehicles are dramatically better than the EVs of just a decade ago, but history shows that industries don't always evolve in straight lines. Sometimes progress comes from improving existing technology. Other times, it comes from questioning assumptions that everyone else accepts. That's what makes this story so interesting. The reported technology isn't trying to win the battery race. It's trying to change the race itself. Instead of asking how much energy a battery can store, it asks how efficiently that energy can be used. That's a completely different perspective. And throughout history, some of the biggest breakthroughs have come from exactly that kind of thinking. The automobile didn't replace horses because it was a slightly better horse. The smartphone didn't succeed because it was a slightly better phone. Major innovations often succeed because they redefine the problem. That's why engineers and analysts are paying attention. Not because the outcome is guaranteed, but because the idea challenges conventional thinking. Of course, there are still many obstacles ahead. The technology must prove itself outside of laboratories. Manufacturing challenges must be solved. Costs must remain competitive. Reliability must be demonstrated over years of real-world operation. Those are significant hurdles. Many promising technologies never make it beyond the prototype stage. But if this system performs the way early reports suggest, it could influence the next generation of electric vehicles in ways few people expected. And even if the final product looks different from today's reports, the underlying ideas may still shape future development. That's often how technological progress works. One breakthrough inspires another. One innovation creates opportunities for the next. And before long, the entire industry starts moving in a new direction. Right now, nobody knows exactly where this story will end. But one thing is becoming clear. The future of electric transportation may be far more interesting than anyone expected. So, has Elon Musk really found a technology that could end the EV race? The honest answer is that nobody knows yet. What we do know is that something has captured the attention of engineers, researchers, investors, and industry insiders around the world. Whether this becomes a revolutionary breakthrough or simply another step in the evolution of electric vehicles remains to be seen. But that's what makes moments like this so fascinating. The biggest changes often begin quietly, long before the headlines, long before the public fully understands what's happening. And sometimes, the technologies that reshape entire industries are the ones nobody saw coming. What do you think? Could this be the next major leap forward in electric transportation, or is the industry getting ahead of itself? Let us know your thoughts in the comments below. And if you enjoyed this video, don't forget to like, subscribe, and turn on notifications so you never miss our next deep dive into the world's biggest technology stories.